Alright, so today we're going to be going over the mean value theorem. So the mean value theorem has two parts to it. So first we're going to talk about Rolle's theorem. So the mean value theorem jumps off of Rolle's theorem. It's a little sector of it. So by the Rolle's theorem, if a function is continuous on the interval of a to b, and then it's differentiable on the interval of a to b, and if fa is equal to fb, then the derivative of fc should equal 0. So essentially what that looks like is, let's say we have a function like this. fa is over here, fb is over here. So fa and fb are equal, and the function is continuous and differentiable. So by that rule, there must be some c value in which the slope is a tangent line, which is also equal to 0, which we can see is down here. And now we move on to the mean value theorem. The mean value theorem is basically the same thing, except it opens up to all values of c. So the mean value theorem is if it is continuous on the interval of a to b and differentiable on the interval of a to b, then f prime of c there should be a c value in which f prime of c is equal to fb minus fa over b minus a. So if you recognize this is a slope formula, which essentially gives you a derivative at a point, and there must be a c value in which when you plug in the b and a values, it gives you the slope at one of the c values within that interval. So by that, the mean value would be true. So let's take a look at number 1. So number 1 is the graph of a function f is shown. Verify that f satisfies the hypothesis of the Rolle's theorem on the interval of 0 through 8. Then estimate the values of c that satisfy the conclusion of the Rolle's theorem. So if you remember, the Rolle's theorem deals with f prime of c is equal to 0. So first what we should do is write down the formula. It's fb minus fa over b minus a. And this is going to be our A, and this is going to be our B. So FB is 3 minus 3, which is also FA, over B minus A, which is, I believe that's 8. Yeah, that's 8. And this is 0. So we're going to have 8 minus 0. So we have 0 over 8, which is just 0. So what this is telling us is that f prime of c is 0 here. So we need to find out the c values, or rather, also known as this x values, in this interval that have a slope of 0, or rather a horizontal tangent line. So we could visually see that there's a horizontal tangent line at f1. So f1 would be our first one, and then there's a horizontal tangent line at I believe this is 5. So x equals 1 and 5 would be your c values, so c equals 1 and 5. And now let's take a look at number 2. So number 2 is draw the graph of a function defined on 0 through 8, such that f0 is equal to f8 equals 3, and the function does not satisfy a conclusion of the Rolle's theorem on 0 through 8. So let's mark that as x equals 8. So if we draw a graph that does not satisfy the conclusion of the Rolle's theorem, so what are the subjects of the Rolle's theorem? It has to be continuous from 0 through 8, and since it is defined, we have to make it continuous, and it has to be differentiable from 0 through 8. Now we could make the graph not differentiable, so what we could do is we could think of an absolute value function. Absolute value equation rather is defined and continuous, but it is not differentiable, because when you have these sharp corners here, what happens to a velocity graph is that it'll go like this and then it'll jump. And when it jumps, if the velocity graph is not a continuous function, then the original function cannot be differentiable. So by that little thing, the fact that it has a sharp corner there, this does not satisfy the Rolle's theorem anymore. And even if you plug in the numbers to the equation, it would still satisfy it, because f prime of c would still be 0. But because it's not differentiable, it does not satisfy the Rolle's theorem. Alright, so let's move on to these few questions. So we're probably going to do 2 out of these 3 questions. So basically here we have to uh, make sure that the equation here and the interval satisfies the Rolle's theorem on the given interval, and then find the c value that basically by the Rolle's theorem the derivative of c is 0. So now what we're going to do here is first we have to, so the mean value theorem equation is going to be f prime of c is equal to fb minus fa over b minus a. So first we have to plug in everything for that so we could make sure that it follows the Rolle's theorem. So f of b would be, we would plug in 3 into the original equation. So we would have 3 squared, which is 9, plus times 2, which is 18, minus 12, plus 5. And then that would be subtracted by negative 1 into this equation, which would be, we have 2 plus 5, and then, or plus 4 rather, plus 4, and then plus 5. And that would be over just 3 minus negative 1, which is 3 plus 1. And here we have 6 plus 5, which is 11, minus, this is also 11, so 11 minus 11 is 0, so we have 0 over 4, which is just 0. And that means that this equation number 9 here does satisfy the Rolle's theorem. And now we need to find the c value. So how do we do that? So in order to find a point at which the derivative is 0, it's basically a tangent horizontal line. For example, like a minimum or maximum value. So what we need to do is find the derivative and then solve for x. So if we find derivative number 9, it's going to be 4x minus 4 and equals 0. We'll just equal it to 0. We move it 4 to the other side. We're going to have 4x equals 4. We divide by 4 on both sides. We're going to have x equals 1, and which would be our only c value. So c equals 1 is going to be our answer. And now let's move on to number 12, because this has a fraction in it. It's going to be a little bit different. So if we jump onto number 12, all we need to do is plug in for the Rolle's theorem function, and then basically confirm it. So if we plug in fb, it's going to be 2 into this original equation. So we're going to have 2 plus 1 over 2 minus 1/2 into original equation. So we're going to have 1/2 plus 1 divided by 1/2 is going to be 2. And then we're going to have 2 minus 1/2. But on the top, we have 2 plus 1/2, which is 2.5, minus 1/2 plus 2, which is 2.5. So we're going to have 0 over, it doesn't even matter what's on the bottom. On the bottom would be 3/2, you could just write it, so it would be 0. So this number 12 does follow the Rolle's theorem. And now what we need to do is find the c values that satisfy it. So what we need to do is find the derivative of the function. So f prime of x is going to equal 1 by the power rule, and then the derivative of 1 over x is a good rule of thumb is to know like the derivative by hand. It's just negative 1x squared. So we would write here negative 1x squared and then negative in the parentheses. And now all we need to do is just solve for x. So if we move this negative 1x squared, 1 over x squared to the other side, we're going to have 1 equals 1 over x squared. And now we can just move this to the other side. So we're going to have x squared equals 1 and x equals 1, which is also our c value. So c equals 1 is the number c that satisfies the Rolle theorem. And to know if it's a valid answer, you got to see if it's within the interval. So 1 is within the interval of 1/2 to 2. And for number 9 as well, c equals 1 is within the interval of negative 1 to 3. And you could see 1 is also halfway in between, but it doesn't always have to be halfway in between. Like here, it's more towards the left. But that's basically how you find the c values using the Rolle's theorem and how to confirm the Rolle's theorem. So I want you guys to try number 5 and 6. So for number 5 and 6, all you need to do is just satisfy confirm if it satisfies the mean value theorem, and then find the C values that satisfy what you got by plugging into mean value theorem. So you can pause the video and try those out. Alright, so let's take a look at number 5. Number 5, we have a little, function going on here. What we could pinpoint is that there's a sharp corner here, so that's not a good sign. But let's continue on with the question anyways. So we plug in for f prime of c. We have fb on the left, and b is going to be over here, and then a is going to be over here. So fb is going to be 2 minus fa, which is going to be 0, over this x value is going to be 1, 2, 3, 4, 5. 5 minus 0. So we're going to have 2 over 5. And so f prime of c is equal to 2 over 5. And now what we have to do is we have to find the part in this graph in which the slope is 2 over 5. And if you could see the graph here, we see that the slope on this interval, it goes down by 1/2, and then it goes down 2. It goes to a right 2. So the slope of that would be negative 1.5 over 2, which that could be written as negative 3 over 4. And now the slope on this interval would be positive. So this goes up 3.5 for every 3, so it'd be 3.5 over 3. You could also rewrite it as 7 over 6. So our two slopes we have in this graph are 7 over 6 and negative 3 over 4. We see that that is not equal to 2 over 5. There's no C value in which it's equal to 2 over 5. That's why I pinpointed that sharp turn at the start. That sharp turn indicates that the derivative function is not a continuous function. It's not differentiable. So by that case, this does not satisfy the mean value theorem. Does not satisfy. So I'd say usually if there's like a sharp corner, you could kind of just make an assumption that it does not satisfy a mean value theorem, but you could also go through the algebra and stuff to figure it out. Let's go to number 6 now. Number 6, so we're going to plug in for the mean value theorem equation again. So we're going to have, this is going to be b and this is going to be a, because that's our interval. And so f of b is 1 minus f of a, which is 1. And on the bottom, we're going to have 1, 2, 3, 4, 5 minus 0. But the bottom doesn't really matter because we're going to have 0 at the top. So f of c is equal to 0. So we have to find the c values that have a derivative of 0. Essentially, what that means is we have to find the c values that have a horizontal tangent, or the x values rather. So we could see that there's a horizontal tangent going on here, and then there's one going on here. And I wouldn't say there's one going on here. This is kind of like an x cubed function going down. But you could kind of say that there would be a horizontal tangent there, just momentarily. And we can't exactly confirm at the end here. So we could say that the c values that satisfy this are 1, and then 3 and 4. So that would be your answer for that. And it does satisfy mean value theorem, because we saw that there are c values that exist that does satisfy the theorem, and it also doesn't have any sharp corners. Alright, so I want you guys to try number 3. So number 3 is going to have 3 parts here. You're going to verify mean value theorem and then find the c values. And then on c, you're going to find the c values on a different interval that's given. So you could pause the video and try that out. Alright, so if you write the mean value theorem here, it's going to be f prime c is equal to fb minus fa over b minus a. And now what we need to do is just plug it in. So for now, this is going to be our A and this is going to be our B. So FB is going to be at 1, 2, 3, or 1, 2, 3, 4. We're going to have 4 minus FA, which is 1, over, we're going to have 1, 2, 3, 4, 5, 6, 7. 7 minus 0. So if we simplify that, we're going to get 3 over 7, and this is 7. 1, 2, 3, 4, 5, 6, 7, 8. Actually, 8. That's 8. So our f prime of c is going to be 3 over 8. And that is going to be our answer for A, since it satisfied the hypothesis of the mean value theorem. Because there is definitely a c value in which it hits 3 over 8, because it's increasing here at a pretty steady rate and then it's decreasing. So by the fact that it's differentiable and continuous, we have to conclude that it satisfies mean value theorem. So let's try B. So estimate the values of C and satisfy a conclusion of the mean value theorem on the interval 0 through 8. So our f prime of C is 3 over 8. Now, since this isn't an equation and it's a graph, we have to estimate it, just eyeball it. So we have to find a point in which the slope is probably 3 over 8 or really close to 3 over 8. So we could kind of estimate I would say the slope at x equals 2 is about 3 over 8, because it is a bit flatlining, but it's still increasing. And I would also say the slope over here is 3 over 8, so our C value answer would be 2, and this would be 6.5. So the thing for B is that the answers are sometimes subjective, since you're kind of eyeballing it, but most times, as long as you're within the realm, you'll get it correct. And now we go into C. So C is estimate the values of C satisfy conclusion on the interval 2 to 6. So now we're working with the different intervals. 2 is over here, and then we're going to have 3, 4, 5, 6. The 6 is over there, so this is our new A of B. So all we need to do is just plug in for the mean value theorem, find f prime of C. So f of B at 6 is going to be 1, and then at A it is going to be 3. And over B minus A, which is going to be 6 minus 2. So we're going to be left with negative 2 over 4. So our f prime of C is going to be negative 1/2. And now what we need to do is just kind of estimate the value in which the slope of the graph is negative 1/2. So the only point at which the graph's decreasing is right here. So it has to be within this interval right here. So I would say the graph is at slope of negative 1/2 around here and around here. It definitely hits it twice. So we could say x equals 3, or this isn't 3, this is 4. X equals 4 and x equals 5. So our answer would be rather C equals 4 and 5. Those are estimations for the C values that satisfy the mean value theorem at interval 2 to 6. Alright, so I want you guys to try number 15, 16, and number 18. So for these, essentially just confirm that it satisfies the mean value theorem, and then using that f prime of C, find the C values that satisfy the conclusion. So you could pause the video and try those out. Alright, so let's take a look at number 15. Number 15 is function f of x is equal to 2x squared minus 3x plus 1. So what we need to do is plug into the mean value theorem first. So the mean value theorem is f prime of c is equal to fb minus fa over b minus a. So we can first plug in fb. So fb is going to be 2 into this equation right here. So we're going to have 4 times 2, so 8 minus 6 plus 1. and then that's going to be minus FA, which is going to be 0, 0 plus 1. So we're just going to have 1, and then on the bottom, we're going to have 2 minus 0. So if we simplify real quick, we get 8 minus 6 is 2, plus 1, which is 3, minus 1, which is 2, and then denominator, we're going to have 2. So our f prime of c is 1 over here. So this is a bit different than we did before. We would usually get 0 before. So now what we have to do is we have to find the c values in which the derivative is 1. So first what we could do is you find the derivative, which is 4x minus 3. Now all we need to do is just equal it to 1. So 4x minus 3 equals 1. Now we add 3 on both sides. We get 4x equals 4, and then if we divide by 4, we get x equals 1. Or rather, c equals 1. So 1 is the c value that satisfies the mean value theorem here. So let's take a look at number 16. Number 16 is something similar. Its function f of x is equal to x cubed minus 3x plus 2. So again, we're just going to plug in for the mean value theorem equation. So we're going to have 2 into this, which is going to be 8 minus 6 plus 2. And then minus negative 2 plugged into here, which is going to be negative 8 plus 6 plus 2. And the bottom, we're going to have 2 minus negative 2, which is just 2 plus 2. And so the top, if we simplify, we're going to have 8 minus 6 plus 2, which is 4. 4 minus, we're going to have here 0. 4 minus 0 over 4. So we're just going to have 1. So basically here, our f prime of c is also 1. So again, we have to find out the c value in which the derivative is 1. So again, we can find derivative of this, which is 3x squared minus 3. And we just equal it to 1. So 3x squared minus 3 equals 1. We could add 3 to both sides. So we get 3x squared is equal to 4. And then now we could just divide by 3 on both sides. And we would get x squared is equal to 4 over 3. And now we just square root it. So we're going to get x equals square root of 4 over 3. And now this is actually a plus or minus square root of 4 over 3. So our c value is radical 4 over 3 and minus radical 4 over 3. So that is our c value for number 16. That satisfies mean value theorem. Alright, so now let's start on number 18. So number 18 is just f of x is equal to 1 over x. So if we plug into a mean value theorem, we're going to have for f of b, we're going to have 1 over 3, which I'm going to write as 1 over 3 minus, we plug in 1, so we're going to have 1 over 1, so we're just going to have 1. And the denominator, we're going to have 3 minus 1. So on the top, we're going to have negative 2 over 3 divided by 2. So negative 2 over 3 divided by 2 is going to give us negative 1 over 3. I believe so, yeah. So negative 1 over 3 is basically our f prime of c. And now what we have to do is find the derivative of 1 over x and then set it equal to f prime of c to find the c values. So we know derivative of 1 over x is going to be negative 1x over x squared. So all we need to do is just set them equal to each other. Negative 1 over x squared equals 1 over 3. And negative 1 over 3. And we cross out negative signs. We can multiply, cross multiply. So we're going to be left with 3 is equal to x squared. We just square root both sides. And we're going to be ending up with x is equal to negative radical 3 and radical 3. And those are our c values. So it would actually be c is equal to radical 3, comma, negative radical 3. And that would be your final answer. Alright, so that was essentially the mean value theorem. And some important takeaways of the mean value theorem is obviously the conditions that it has to get right is that the function has to be continuous and differentiable. Differentiable is essentially when the derivative functions are also continuous. And it has to be able to plug into this, and you have to be able to get a c value that exists. And the same is true about the Rolle's theorem, except the Rolle's theorem, the f prime of c is always 0, so you could remember that. But essentially, this is just kind of making sure a function is differentiable and continuous. So yeah, that's basically it.